Okay, these are your notes for sections 12.3 through 12.5, and in this video we're going to talk about odds. Now, before we get started, we're going to recap a little bit and get some vocabulary. Independent events, remember, are events that do not affect each other. Dependent events do affect each other. All right, some new vocabulary. Outcome is the result of an event. So, for example, I roll a dice, I got a 6. That's the outcome, okay? That's the result of what I did. It's the result of one trial. I have 10 marbles in a bag. I put my hand in, I pull out 1. That's an example of an outcome, whatever marble I got, okay? Sample space is the total number of outcomes. So if I'm rolling a dice, I have 6 possibilities. So the sample space would be 6, and my outcome, if I got a 5, I'd have one option to get that 5, okay? Now all that ties into odds, because odds is the ratio of an event's success to its failure. And it's written like this: success to failure. So the outcome, you want it to be a success. However many options you have that you can receive your outcome, that's considered a success. Now the sample space comes in because my success plus my failure should equal my sample space. And this is a common mistake people make. They usually write it success to the sample space, all of your outcomes, but it's written success to failure. Okay? Here's a quick example. I have a coin. I'm going to flip a coin. I want to get heads. All right? There are 2 sides to a coin, so there's my sample space. If I want to get heads, I have one option of getting heads. That's my success. And then I have tails, which is my failure, so it's written 1 to 1. All right, I have one option for success, and then one option for failure. I add 1 and 1, I get 2, which is the total sample space for the problem. I flip the coin, I have 2 sides, that's the sample space. Okay, we're going to look at a couple examples here. All right, number 1. It says to give the odds. Number 1, rolling a 1 on a standard dice. Well, let's talk about our sample space first. 6 sides to a dice, so my sample space is 6. Now remember, I'm writing this success to failure. Alright? Well, I have one choice to get a 1, one option to get a success, and then 5 chances to get a failure. So I'd write it 1:5, 1 to 5. To check it, I add 1 and 5, and I get 6, which is the total sample space for the problem, so it makes sense. I did the problem right. Number 2, rolling a number that's divisible by 3 on a standard dice. A little different. We got to think a little more. Sample space, it's still a standard dice, so my sample space is still 6. Now I have to figure out how many numbers on a dice are divisible by 3. Well, number 3 is, and number 6. So there are 2 choices for success. So I would write it 2, 2, and then I want my failure. If I did 2 of them, 2 of the 6 are success. 6 minus 2 is 4. So I'd write it 2 to 4, and that can be simplified to 1 to 2. All right? So it ends up being 1 out of every 2, or 1 success for every 2 failures. All right? Last example, and it's got 3 parts to it. These are written as fractions. Now, when we have a fraction, the top, the numerator, is your success, and the denominator is the sample space. And that throws a lot of people. Most people will go for this, 8 to 9. That's not correct. because remember it's success to failure, and the denominator is the sample space. So the correct answer would be 8 to 1. Because I add 8 and 1 and I get 9. So really all I'm doing is taking my denominator, subtracting the numerator from it, and that gives me my failures. Alright, B is 1/6. So we know our success is 1, and then 6 minus 1 is 5. So there would be our answer, 1 to 5. Last one, 2/9. We start with 2. 9 minus 2 is 7. So there would be our answer, 2 to 7. Now, if you have any questions on odds, go back and watch the video, and if you still have questions, bring them to class next time.